Okay, so we have some reduction reactions up here, and it is our job to decide which of these three reducing agents to use on benzylic ketone, ketone, and benzylic ketone. So ketones and aldehydes, especially in benzylic positions, doesn't have to be, but those are most commonly what we're going to be given here. I tried to find other examples that were used in class, but the ones in the book are the exact same ones that Dr. Andrews used, unfortunately, and I can't find anything online. I could make up some of my own, but I think because these are I think these are tough. And I think if we just know the three that are in class, we are most likely to be okay for the assessment. Not to say that there might be a different functional group on there, but I think it's highly unlikely. I think if we focus on these, we'll at least get the purpose down. And the only other shot that there might be something different is if there's a functional group that's either acid or base liable and would react with one of these. But I don't think she'd throw anything else that's not on any other functional groups that would react. It's not already up here. So we're gonna go over these. My three options: in blue, I have Wolff-Kishner. In red, I have Clemenson. And in green, I have Rainey-Nickel. The reason we have three of these, notice, basic conditions. So if I use Wolff-Kishner, everything that's base liable or is going to react with a base, not good. And so if I have something that's going to react with a base, I'm not going to want to use Wolff-Kishner because it's going to then react with that. And also my ketone or aldehyde, I want to select only for my ketone or aldehyde. So under basic conditions, I have something that's going to interact with that base. We're not going to use Wolff-Kishner. Likewise, in our Clemenson, we have highly acidic conditions. So I have a ketone or aldehyde over here, but then I have something that's going to react with an acid. Not good. I'm not going to want to use Clemenson. Lastly, with Rainey-Nickel, I'm going to create a thiol acetal. Basically this here with our sulfurs, this is going to act as a nucleophile. So anything that's going to, if I have some other functional group in my compound that might react with a strong nucleophile or mid-nucleophile, I'm not going to want to use Rainey-Nickel because it's going to react with that and not my ketone or aldehyde. So we're going to use these to select to reduce only a part of our molecule without interfering elsewhere. So overview, if I have something that's going to react with a base, I'm not going to use Wolff-Kishner. If I have something that's going to react with an acid, I'm not going to use Clemenson. And I have something where we think a nucleophile can add, we're not going to use Rainey-Nickel. Okay. None of these are strong enough to interrupt with benzene. Some of our metal catalysts can, but it has to be like 100 atmosphere pressure. But benzene we're not going to touch, ever, really. Okay, so in our first molecule, we see that we had a benzylic ketone, and now it is gone. What other functional groups do we have? An alkene right here, okay? So we didn't get rid of our alkene. Oops. We didn't get rid of our alkene. We just want to react with our ketone, okay? Now, which of these is going to work best? I would ask myself, which one is not going to work, okay? We need to eliminate two options until we're left with one. Or we could have multiple that work, but usually I think going by process of elimination here is going to be most helpful. Okay, our answer is going to be Wolff-Kishner, so I'm going to skip that one, and I'm going to go to Clemenson. Why won't Clemenson work? We have a double bond here, a benzylic double bond, so if we have HCl and a double bond, we've done this reaction before, but we can add, this would be substitution reaction, HCl, benzylic double bond, I would have the hydrogen add here, Cl add here. Basically, I'd get a very, very strong double, let me actually show that. If I react this with HCl, who has electrons and who wants them? Double bond, hydrogen on the chlorine there. Then I'm left hydrogen on it right here. Very stable carbocation, so good reaction. My Cl minus will attack, and notice I don't get that in my product. It's just going to interfere. I'm not going to use Clemenson because my highly acidic conditions, HCl, are going to interfere with that alkene. So if you see an alkene and it is conserved, don't use Clemenson because our HCl is going to add on that double bond. Okay? So if I were to react this with Clemenson, I would likely get something like this. But we don't want that. We want our double bond to stay there. Similarly, I will not use my nucleophile and Raney nickel for a very similar reason. Okay, I would get an addition over here with our double bond. It's not going to be good. Okay, and if I look at my basic compound, my Wolff-Kishner, I'm not going to perform a base reaction here. I'm not going to want to take a proton off of anything and put a double bond in here anywhere, okay? Just not going to work. There's nowhere where I'm going to want to make, take a hydrogen off and put a double bond. I'm fully conjugated as is. And we decided, because these two would not work, that our answer should be Wolff-Kishner. These are difficult, I think. But again, I wouldn't be surprised if almost one of these identical problems showed up. So I think if we get these three down, we'll be okay. You're gonna ask yourself, where is the functional group that's conserved and how do I avoid not messing it up, basically. Okay. So here, the second problem, I see that my halogen, my bromides, my halogens are being conserved, and I need to get rid or reduce this carbonyl up top. Okay? Let's start out with Wolff-Kishner. Wolff-Kishner work. Are these halogens going to maybe do something under basic conditions? Yes. Okay. I could take an alpha proton here, basically, form a double bond, and I'd have good leaving groups. If I see halogens, not going to use Wolff-Kishner. Base is going to strip those off. Okay. If I have a strong nucleophile and a good leaving group, I can perform substitution reactions. If I see bromines, if I see chlorines, fluorines, I'm not going to use Raney nickel either. Substitution and they're gone, elimination and they're gone. However, if I have something like HCl, I'm not going to replace a big halogen with another big halogen. Okay? I'm not. There's not going to really be a substitution between bromine and chlorine. Okay? So when I see that halogens have to be conserved, I'm going to use my Clemenson for that. So we saw up here, if I'm using a double bond, we know it's going to react with these two, so I'm left with Wolff-Kishner. If I have halogens, they're going to react with these two, and I'm going to use Clemenson. Last example here. Okay. Okay. Now we get to our last one here. Let's start out with why. Let's look. We'll just start here at Rainy Nickel. Rainy Nickel. Okay. My functional group that's being conserved is this tert-butyl group. Okay. Tert-butyl group. Our Rainy Nickel conditions are slightly acidic as well. So if I use something that's acidic with an ether or an ester, so, oh, it's not up there. So an ether or ester, they're going to protonate in acidic conditions and leave. That's going to eliminate my Rainy Nickel and my Clemenson. Under basic conditions though, again, there's nothing here that I'm going to perform an elimination on. I've decided that these are acidic and these are going to put my ethers or esters, either one. Here these are ethers, but if we had esters, they would do the same thing. That they will protonate and then they will leave. So if that needs to be conserved, I would need to use Wolff-Kishner. So overall from these, our double bonds, if they're being conserved or we're preserving an ester or ether, I'm going to use Wolff-Kishner. If I want to keep halogens on there, I'm going to use Clemenson. If I had something where it was acid and base liable, but not necessarily going to react with a nucleophile, then I would use my Rainy Nickel. Identifying that is it's difficult, and it's not something we've gone over much at all. And it's tough to find other resources for it, unfortunately. I think with these three though, I don't think she's going to go outside of halogens, double bonds, and ethers. I don't. I can't guarantee that, but this is what's provided, and this is the reasoning for it. I wish I had more. I don't in the meantime, or currently. In the meantime, I will, I think we're going to go to oxidation next, and we're going to go over that. But again, because it's such a short time for an assessment, I think she's going to stick with this. I hope she does. I kind of went too in depth, I think, with last assessment, but you never know what's going to be on there, so it's better to do more than less. But this is what we're working with here. Double bonds, ethers, halogens, and why we select using different reductive agents.